Recording now on my laptop. I'm gonna check my phone. We are recording, so I'm gonna try to sync them up, hopefully. So 1, 2, 3, 4, 5. I don't know, people do that, and so hopefully that they're synced now. So let's show the camera first what we have. This is the instrumented crutch. I think you can see it. Yeah, this is the instrumented crutch. All the electronics are in this box here. There's a cable just to connect to someone's laptop for the live output. Essentially, there's a couple layers which I could show on the desktop as well. There's the platform, the original Crutch platform. There's a bunch of 50 kilogram load cells which you see in like bathroom scales. A 3D printed knee platform that goes on top of the load cells, and just some cushion for comfort, which came with the Crutch. But essentially, when you start the program, there's an Arduino inside that will tear all the sensors. So all the weight of the platform and the cushion doesn't matter. So I'll plug it into the laptop. It'll start the Arduino and it will tear the sensors once we start the serial, once we start inputting serial like information. So I'll start the processing IDE, and we should get, so when it says null, which I'm looking at the desktop right now, this error just means that we're initializing the sensors because it doesn't send out numbers. So you just stop it and run it again. And so now we know that they've been teared, and if you see a black screen, that's actually good because I'm not wearing it yet. So now that it's recording, I'm gonna wear the crutch. So it's gonna look messy in the Excel, like it's gonna save everything to a spreadsheet at first. But in the end, it's not going to look, you can tell when we take steps. But as we're putting it on, it will look a little messy at the beginning. So just to preface that. So I'm going to strap myself in with the included straps. As you can see, I'm starting to walk a bit, and there's some output on the desktop. But essentially, this is what the crutch looks like underneath that platform. There's 4 sensors. This is the topmost one. And as you go forward, these correspond to each of these circles up here. And the green circle is the center of force. So as I'm standing, everything's pretty stationary. All of the circles are in the same sort of size. So the size corresponds to how much force each one reads. And the green one will change size based on the total force on that entire platform. So I'm going to now mimic the student walking. Typically, you have another co-op student holding the laptop so they don't have to worry about it, but just me will start going now. So about 1, 2, 3 steps, pretty good. And so this is mimicking sort of a walking, someone walking. So I'm going to do it again here. And the key information is when each of the sensors reach their peak force reading, and also their maximum force being read. So if you notice, that green circle is staying closer to the front where the knee is, because that's where most of the force is being felt by the platform. And so each of these data points, they can be used in the FEA that students will run through, which will generate sort of a stress distribution along the crutch, which they can use to select different materials and see which one fits best for this crutch based on like weather conditions. If the floor is slippery, use rubber. What does wood do? Stuff like that. So I'm going to do a couple more walks here, sort of showing the output on the screen. Just a little bit more. Now typically students will run for about 20, 30 seconds, but I'm just going to exaggerate it just so that I have more data to show. So I'm going to walk better. So again, I'm standing right now. If I want to walk forward, I'm going to put my leg out, my initial heel strike, and as I let go of my leg, or not let go, but sort of move on to the next step. So this is the typical walking gait of someone. So 1, 2, 3. And the purpose of the live output is for the other group members who are running through the activity to actually see what is going on and see the output as one of the students is walking. Alright, and I'm gonna circle back around, and I think that should be good. So as I'm going, the crutch itself is actually comfortable to wear. It feels about the same as the normal crutch. And so we're just gonna use my entire walking stage. So like this 5-minute recording is just data collection. I could select in the Excel sheet which ones I want to use for the FEA. So one last, I'm gonna go back. Oops, almost fell, but I'm gonna go back. 1, 2, and 3. Okay. So now I'm gonna stop my phone recording, and I'm gonna move on to the desktop recording. I'm gonna get myself strapped out. And so the students, it takes about 5 minutes in total for like one group to go through it. But essentially what we've done now is if we stop this program, it's saved to a folder group 1, Gavin Tranquilino 2. This is the second, or actually the third time I'm recording this video because I keep messing it up. But if I go now to, if I open that folder, maybe in here, I'll browse for it. So it saves as a CSV file right here. So I could open it. And so this is the recording output. This is what we just recorded. We have a column for the elapsed time. So when the program starts, it starts at 0. And 10 times per second, it's going to take a recording of what each sensor feels. So cell 1 corresponds to the topmost circle. Cell 4 is the bottommost circle, which is closest to your ankle. And the total force is just the force across all 4, summed up. And so what students can do now is if they take these set of values here, and they insert a scatter plot, just like this. Now this entire graph is a graph of force over time, where each peak represents a step taken, which looks really messy, but how do you interpret this? We can zoom in on some important parts. So if you notice, from about 0 to 50 seconds in, that's just me explaining the video when I started the program. But what they could do, if they go to their options in the Excel file, let's zoom in on, I don't know, like 100 to 110 seconds. So again, they'll click on the plus sign, go to the axes, more options. In the options here, we can select the data that we actually are interested in. About a 10-second recording is pretty good. Let's go 105 to 115. 105 to 115. That looks better. So each one of these peaks here is one step that I took in the video. And if you notice, so series 1, 2, 3, 4, this corresponds again to the sensor numbers. So you see the most force is on the one right under the knee, and each of the other sensors are sort of less than that, but they happen at relatively the same time. But you can see the orange versus the blue kind of lags just a little bit. So that is something interesting in the walking gait that students can try to interpret. But basically from these values then, they can pick at some timestamp, like right here at pretty much 108 seconds, this recording here of each of like the 4 sensors right here. So I find that in the file at 108 seconds. If we scroll up, or I think 108, just about right here, they can use like a value right here. It sustains at about 90 or 900 newtons. I missed it. But essentially they'll use the 4 values here. They can import it to the CAD model that we've built, just like this. And what ends up happening, they can visualize the simulation using their own data and sort of see the stress distribution, and they can do their material selection from their own data set. So that's the purpose of the crutch. And hopefully that video has shown enough information on how to get started, the design of the activity, and how to run the activity, and how to show students how to interpret their data. So I think I'm good there. I'm going to stop the recording and move on.